Alright, today we're going to go over 1.7 homework part 2. Starts on page 54 to 57, and then it's 24 to 64 even. I'm doing this without headphones to see if it's my phone that is being all weird, and that's why this last couple of videos have been at sound, or if it's the headphones I was using. So this is kind of like a test. If you hear any tapping while I write, I apologize. I'm just going to have to deal with it while you run this test run. Alright? Now, this is the hint sheet from the board, and it's going to be the main focus of this. Today, we're going to focus on steps for completing the square. So, step 1 is going to make sure we have x squared plus bx on one side of the equation. That means by itself. So, if there's a letter, get rid of it. If there's a number over there, get rid of that number. And the important part is it should be a 1 in front of its x squared. So, it's not just any x squared, it's just 1x squared. Once we do that, we're going to create c by doing this formula, c equals b over 2 squared. And the most important part is we have to add it to both sides. Most people forget to add it to both sides. It's the most common mistake. So, good rule of thumb is if on one of these problems on part 2 and you did not use b over 2 squared, you probably made a mistake. And then the last thing is we're going to factor the perfect square trinomial that we created into some parentheses squared. So then we can use Pemdas backwards. All right. Now remember from previously, a perfect square has 3 terms that begins with a perfect square, and it lets us go to this. One set of parentheses squared. Here's a list of perfect squares. Here's Pemdas backwards in case you're lost there. And that's the hint about b over 2 squared. Pretty simple. Alright, number 24 is x squared plus 6x minus 3 equals 0. If I look over here on this back to my hint sheet, I'm going to see that I need to make x squared plus bx on one side of the equation. And I look over here, I have that minus 3 on this side of the equation, on the left side. So I'm going to get rid of that minus 3. So in order to do that, I'm going to add 3 to both sides. Now I'm going to write this as x squared plus 6x. And I'm going to put a space here on purpose, just to save me some space. If you don't want to write this space out there, you don't have to. Now I'm going to change colors. And that's where because I have x squared plus cx, I know I have to find c. So c is equal to b all over 2 squared. In this case, b is the 6. So I take half of 6, which is 3, and square it. 3 squared is 9. Now remember, this number that when we do c, it's always going to be positive because a number squared is always positive. So if you end up getting a negative answer, it's probably because you made a calculator mistake. Now I'm going to take this 9, I'm going to add it to both sides. I'm going to add 9 right there. And I'm going to write there. So don't forget to add that to both sides. That's why I like to change the color, because now it's really easy to see I have C. I see plus sign on the left side. I see plus sign on the right side. So now I'm going to go back to yellow. And this is going to turn into x squared plus 6x plus 9 equals 12. I usually skip this step right here and just write it as one set of parentheses squared, but for this problem, I'm going to show you how I got it, kind of a long way. How do I get x squared, x and x? How do I get 9, 3 and 3? The square roots give me, add up to be the middle. So I can write this as x plus 3 equals 12. Notice I don't have 3 anymore, I have 12. That's one set of parentheses squared because those parentheses match. And now I can use Pemdas backwards. So if you don't remember Pemdas backwards, look back on the hint sheet right here. This is where I'm going to be looking for Pemdas backwards, right here. I got to get rid of the exponent before I get rid of the plus, because that addition is actually inside the parentheses. So I'm going to square root both sides first. Remember, the square root and the little 2, they cancel each other out. So the only thing that happens on the left side is x plus 3 shows up all by itself. Now remember, because I had a letter inside that square root, plus or minus showed up right there. And then I have the square root of 12. Now, the parentheses are gone, so I have minus 3 from both sides. I get x equals minus 3 plus or minus the square root of 12. Now, the square root of 12 is the square root of 4 times 3. 4 is perfect, he gets to come out as 2. 3 is not perfect, so he stays in jail forever, so that's your final answer. So remember, guys, when I broke down 12, I don't care about all the factors of 12 that aren't perfect. I only care about the perfect factor. And that 4 turned into this 2 right here, and the 3 stayed in jail forever. So you don't have to write it twice because you can't do negative 3 plus 2 radical 3 in your head. Right, but there is two answers there. If you wanted to write it twice, you totally could. All right, 26. I'm going to go through the exact same concept. I have three themes on the left side. I only want two, so I minus 86 from both sides first. So I end up with x squared minus 18x, and I'm going to put a space, equals negative 86. Since I have x squared, and remember it's a 1x squared, I know that I'm ready to go on, so I'm just going to put my c underneath. C equals negative 18 all over 2 squared, which is negative 9 inside the parentheses squared, which is positive 81. So I'm going to add 81 here, and I'm going to add 81 there. Remember, this is now a perfect square trinomial. So when I go on to my next step, I now get to say this is x minus 9 squared. A lot of people had plus 9. Remember, the minus in the middle, in front of the 18 makes it the middle minus 9. And then negative 81 plus 86, or negative 86 plus 81 is negative 5. I square root both sides because now on the Pemdas Backwards. I get x minus 9 equals plus or minus the negative inside that radical turn into I, and 5 stays in the square root. Add 9 to both sides. I get x equals 9 plus or minus I radical 5. Remember, 5 is not perfect, so it just stays in jail forever. And you just leave it just like that. And that's it for 26. All right, so 28, I have 2k squared plus 16k equals negative 12. Now, remember, although k squared and k are on the left side, there is no number there. I cannot find c yet because of that 2 right there. It has to be 1k squared. So the first thing I'm going to do is I'm going to divide everything by 2. So that changes this problem into k squared plus 8k equals negative 6. Now that original problem is basically gone. I don't come back to that. That's the most common mistake I saw, is that somebody would come back to that. And I'm going to rewrite this a little bit because I forgot my space. So I want my space, negative 6. Remember, the original problem is gone. So now I'm going to switch colors because remember, c is always something new. I always create c. So I say c is equal to 8 over 2 squared, which is 4 squared, which is 16. So I'm going to add 16 on the left side, and I'm going to add on the right side. Like I said, most common mistake is people forget to add that to both sides. Now my left side is now a perfect square trinomial. This is now a perfect square trinomial. That's what PST stands for. So I get to rewrite this, because it's a perfect square trinomial, as k plus 4 squared. Notice 8 over 2, same thing as 4. Notice 8 over 2, half of b is always inside the parentheses. Negative 6 plus 16 is positive 10. Now I can square root both sides. I end up with k plus 4 equals plus or minus radical 10. Now a lot of people think that 10 can be broken down because it has factors 5 and 2, but none of those factors are perfect, so it just stays radical 10. I minus 4 from both sides, so my final answer is k equals negative 4 plus or minus square root of 10. And that's it. Alright, 30 is very similar to 28, except this time the number in front of x squared is not 4, or 2, it's 4. So I'm going to divide everything by 4. Every single thing by 4. Now this becomes x squared minus 10x minus 3 all equals 0. And now it looks very similar to 26. So before I define c, I still have to get rid of this 3 on both sides. So I add 3 to both sides. I end up with x squared minus 10x, there's my space, equals 3. Now I'm on to find c. Okay, I switch colors just to try and show you that c is not part of the original problem. I'm making c up by taking negative 10, which is b, all over 2 and squaring it. So I get negative 5. Remember, that's in parentheses before I square it, so it becomes positive 25. So I have to add this 25 to both sides. Now, my left side is now a perfect square trinomial. So this is a perfect square trinomial, which means I get to write this as x, half of b is 5, minus 5 squared. 3 plus 25 is 28. I have x minus 5 squared equals 28. I get to square root both sides. I get x minus 5 equals plus or minus square root of 28. I add 5 to both sides. X equals 5 plus or minus the square root of 28. Now remember, 28 is not perfect, but 4 goes into 28 7 times, and 4 is perfect. So my best answer is x equals 5 plus or minus, instead of 28, it's 4 times 7, and 4 gets to leave the radical as 2, and 7 stays in jail forever. So best answer is 5 plus or minus 2 radical 7. And that's it for 30. Alright, 32 is just like 30, just like 28, where you see the number in front of t squared is 7, so I'm going to divide everything by 7. This time I end up with t squared plus 4t plus 8, all equals 0. Now it looks like just like something we've done before, so I'm going to minus 8 from both sides because I want the t squared plus the t part, in this case it's 4t, all by itself on one side, it's equal to negative 8. Now, because I have t squared and t all on one side, I'm going to find c. So c is equal to 4 over 2 squared. Half of 4 is 2. 2 squared is 4, so I'm going to add 4 to both sides. Now, the left side is now a perfect square trinomial. That's a perfect square trinomial. So this left side turns into t plus 2 squared equals negative 4. So I have t plus 2 squared equals negative 4. I square root both sides. I get t plus 2 equals negative. Inside the radical makes I show up. 4 is perfect, so it turns into 2. So the radical just disappears. It's still plus or minus, though. The reason I have plus or minus is because it was the square root of a letter. So then I subtract 2 from both sides. I get negative 2 plus or minus 2i. You don't have to write this twice, but if you really wanted to, you could say t equals negative 2 plus 2i, or t equals negative 2 minus 2i. You could have done that on all the problems, but I would take this for full credit. And that's it for 32. Alright, 34 is just like all the problems we've done so far. I want x squared and x on the same side, so I get rid of the minus 8 first. I end up with x squared plus 10x equals negative 13. Now, I want to do my c. c is equal to b over 2 squared, so I have 10 over 2 squared, or half of 10, which is 5 squared, which is 25. So I add 25 right here, and ends up with the left side now being a perfect square trinomial. So this turns into x plus 5 squared equals negative 13. I get the square root both sides. I end up with x plus 5 equals plus or minus the negative. Comes out as I, square root of 13. Subtract 5 from both sides. X equals negative 5 plus or minus I radical 13. And that's it for 34. Alright, 36 has a parallelogram. It has the height. I don't know if it'll let me write on top of it or not. We'll see. Yep, it has a height right there, which is x. It has x plus 6 as the base. So it says the area is equal to 48. So you have to know that the area of a parallelogram is base times height, or length times width, where the base is x plus 6, and there's our height. Alright, so back to that's a little bit easier to see now. The height is x, and the base is x plus 6. So I'm just going to plug in everything I know into this formula. So I'm going to say 48 equals base, which is x plus 6, times the height, which is x. Now this right side kind of looks like pizza liver, guys, so I'm going to do that, and I get 48 equals x squared plus 6x. Now I'm already ready to do c, because on the right side I already have exactly what I'm looking for, where I have x squared plus with a bx. So I say c equals 6 over 2 squared, which is 3 squared, which is 9. So I add 9. Make sure you add 9 to both sides. So I plug that in. Now remember, it's really easy because the right side is now a perfect square trinomial. So this becomes x plus 3 squared, and 48 plus 9 is 57. I square root both sides. I get x plus 3 equals plus or minus the square root of 57. I minus 3 from both sides. Now this one I'm going to split. I'm going to say x equals 3, negative 3, plus radical 57, or x equals negative 3 minus square root of 57. The reason I have to split this is because when I actually have to plug both these in my calculator. When I plug this one in, I get a positive answer, and that's possible. You can have a positive height. When I plug this one, I get a negative answer in, and you can't have a negative height, so that's impossible. All right? So there's actually only one answer, negative 3 plus radical 57. All right, so 38, we have this trapezoid. They tell you that the area is equal to 20. So I'm going to use this formula, which I gave you. It says b1 plus b2 times the height all over 2. If you want to multiply both sides by 2 to start, and you have 2a equals just the top of that equation, that's okay. But I'm going to leave it the way it is. I'm going to plug in 20 for the area. Base 1 is x plus 9, plus the base 2, which is 3x minus 1. Then multiply it by the height all over 2. Now the first thing I have to do is I have to combine my like terms inside the parentheses. So this is going to turn into 20 equals 4x plus 8, because 9 and negative 1 is 8, times x, all over 2. I'm going to distribute the x. I'm going to get 20 equals 4x squared plus 8x all over 2. Now, 2 can divide by both of them. So this is going to turn into 20 equals 2x squared plus 4x. Now it kind of looks like 22. It kind of looks like, it actually looks more like 28. So the first thing I'm going to do is I'm going to divide every single thing by 2. And I'm going to get 10 equals x squared plus 2x. So now I have my c. So c is equal to 2 over 2 squared, which is 1, so I'm going to add 1 to both sides. So then I get the right side turns into x plus 1 squared, equal, and the left side turns into 11. I square root both sides, and then I subtract the 1, so I get x equals negative 1 plus or minus the square root of 11. Now I have to plug these in. I find out that negative is impossible, so my only answer is x equals negative 1 plus the square root of 11. Because when you plug in the negative, it's impossible because you can't have a negative height. So that's your final answer for 38. Alright, 40 was completed in class, so you don't got to worry about 40 unless you didn't do it. Then you got to do it on your own, so you should have listened to me in class. If you weren't here, just come see me and I'll walk you through it. Alright, 42. Although there's a y there, right, it's very similar to what we've done before. Now remember, vertex form looks like this. Y equals a x minus h squared plus k, where vertex form looked like this. Y equals a x squared plus bx plus c. So basically, you're going to take something from standard form and put it into vertex form. Biggest key to realize here is that the a's don't change between forms. So that's going to be difficult. It's going to make it more difficult when there's a number in front of the x squared. But in 42, there isn't. So I'm going to look at 42. Just imagine that y is not there. And it looks like a problem we've done before where the first thing we've done is got rid of the 1. So we're going to do that. Now normally, the number on the left and the 1 combine. This time they don't, so you just write y plus 1. Don't be somebody who combines those letters, the letter with the number, because they're not like terms. Now I have x squared minus 4x. The left side looks like something we've done before, so I'm going to find c, just like I've been doing the whole time. So I'm going to go through, I'm going to find c. c is equal to negative 4 all over 2 squared. Negative 2 squared is 4. So that means I'm going to add 4 to both sides. Now, my left side got a little bit different. It turned into y plus 5. The right side, this is a perfect square trinomial. So it's going to turn into x minus 2 squared. Now, the only difference between this line that we're at right here and this is the k is on the right side. So I have to move this 5 over. I have to minus 5 from both sides. I end up with y equals x minus 2 squared minus 5, where a is 1, h is positive 2, k is negative 5. That means the vertex is 2, negative 5 is the vertex. Alright? So that's what they're looking for. They wanted the vertex and the vertex form equation. And that's it. So once again, I'm going to treat this just like I did 42, where I'm going to get rid of the 90 first. Alright? You cannot combine y and 90, so I just make it y minus 90. Now on the right side, I have x squared and bx all by themselves, just like our steps said before. So nothing's changed, so I have to find c. So c is equal to 20 over 2. Half of 20 is 10. 10 squared is 100. So I add 100 right there, which means I add 100 on the left. Now that I got that, the left side turns into y plus 10, because negative 90 plus 100 is 10. And this is a perfect square trinomial, so it turns into x plus 10 squared. So I just have to minus 10 from both sides, and I end up with y equals x plus 10 squared minus 10. So my a is 1, my h is negative 10, because we don't trust anybody hanging out in the parentheses with our x, and k is negative 10. So that makes our vertex negative 10, negative 10. And that's it for 44. Alright, 46 is harder because it has g of x. Remember, g of x just means y. And also it's harder because the middle number b is a odd number, which just means fractions are going to show up or decimals. So just leave it in fraction or decimal form. I'm going to leave it in fraction form. So first thing I'm going to do is I'm going to minus 2 from both sides, just like I've always done. I get g of x equals x squared plus 7x. So nothing changes. I still got to find c. And I'm going to use it the exact same way. We're going to say c is equal to 7 over 2 squared. So that I'm going to just write that as 49 over 4. And I lost the minus 2 right here. That should be minus 2. So now I'm going to add 49 over 4 to both sides. I'm going to add 49 over 4, which if you don't know that, that's 12 and a fourth. And I'm going to add 49 over 4 over here. I'm going to rewrite that. So this is minus 2 from the right here, and then I'm going to add 49 over 4, which is 12 and a fourth. So now the left side is going to turn into g of x plus 10 and a fourth. Because I had 12 and a fourth and I took away 2. Now the right side is going to be x plus 7 halves squared. Now I don't have to know the factors of 49 over 4 because I know that 7 halves and 7 halves are the square roots and they're the factors because I used c because it's the same every time. Half of b is always what goes right here. So all I have to do is actually just subtract 10 and a fourth. Or sometimes that's called 41 over 4. So g of x equals x plus 7 halves squared minus 10 and a fourth. Like I said, that might be 21, or it might be 41 fourths as well. So now a is 1, h is negative 3.5, k is negative 10.5. So my vertex is negative 3.5 or 7 halves, and negative 10 and a fourth, or maybe negative 41 fourths. And that's it for 46. All right. So previously we divided everything by 5 in order to make that 5 go away in front of the x squared. This doesn't work because on the left side is y. So So you cannot divide everything by 5. It's just going to make things really messy. So what you have to realize is that the A's don't change. So this 5 is going to go outside the parentheses. Now before I do anything with that, I'm going to get rid of this 7, just like we've done before. So the left is y minus 7. But now I'm going to take this 5, I'm going to kick it outside the parentheses because that's what happens right here. Now that makes things a little bit easier because now I just do 5 divided by 5. That's how come the x squared is just there. And I do 10 divided by 5 to get 2x. So inside the parentheses looks like something we've done before where it's just an x squared and an x. So I get to find my c. c is equal to 2 over 2 squared, which is 1. So I'm going to add 1 here. Now normally I add 1 on the other side, but because of that 5 there, I actually have to add 1 times 5, which is 5. So although this is the one time it doesn't look like we added the same to both sides, but we actually did. So I get y minus 2 equals 5. The parentheses right here is a perfect square trinomial. It turns into x plus 2 squared. I add 2 to both sides. So I get y equals 5x plus 2 squared plus 2. Or x plus 1, sorry. X plus 1 here. Now, a is 5, h is negative 1, and k is 2. So my vertex is negative 1, positive 2. And that's it for 48. Alright, 50. The only mistake they did is when they have x equals negative 5 plus or minus square root of 12. 12 is 4 times 3. And when you take 4 out of the radical, it has to change. So x is negative 5 plus or minus 2 radical 3. Not 4 radical 3. Everything else is perfect. Alright, 52 is a little bit difficult because it's going to have that even number in the middle, which makes it really messy when we go to get our new c. So I move 20 over just like we've done in every problem so far, so then I can find c. Now the problem is when I do c, it's 9 over 2, which is not even. So 9 halves is the same thing as 81 over 4, or 20 and a quarter. So I'm going to add 81 fourths to both sides. Now the good news is negative 20 plus is 80 over 4 plus 81 over 4. So the right side is going to be just 1/4. So this actually gets kind of easy. So it becomes, although we don't know, you might have a hard time seeing it. This right here, perfect square trinomial, is just x plus 9 halves squared. Because remember, whatever half of b is goes right there. I add these two up, and I'm going to get positive 1/4. So now when I square root both sides, it's actually pretty easy. Because I get x plus 9 halves equals plus or minus. The square root of 1/4 is just 1/2. So now I have x equals negative 9 halves plus or minus 1/2. And I have to write two answers because I can do both of those. Negative 9 halves plus a half is negative 8 halves. So x is equal to negative 4. Negative 9 halves minus half is negative 10 halves. So x is equal to negative 5. And those are my answers. Alright, 54 is a little difficult because there's two different q squared. So I have to minus 2q squared from both sides. I end up with 5q squared plus 10q equals 155. Now I have to divide everything by 5. So I end up with q squared plus 2q equals 31. So now I can find c. c is equal to 2 over 2 squared, which is 1 squared, which is 1. So I add 1 to both sides. So now I have, on the left side, I have a perfect square trinomial. So this becomes q plus 1 squared equals 32. I square root both sides. I get q plus 1 equals plus or minus the square root of 32. I subtract 1 from both sides. And I have to realize that 32 is 16 times 2. 16 is perfect, so my final answer is q equals negative 1 plus or minus square root of 16 is 4, and 2 stays in jail forever. Alright? So I'll finish the rest of this tomorrow, but I got up to 54 done for you.